Hey everyone, today I will discuss about one of our largest machine learning powered promo optimization engine at Gojek. 4.5 years back, when I came to Indonesia for the first time, I took my first Gojek ride. I talked to this my Gojek driver. His name was Pak Ali, and I was actually quite amazed by the story that he gave to me. So prior to becoming like a Gojek driver, he basically depended on um, day-to-day job actually. So he's part of informal workforce in Indonesia. And then he told me that since he became a Gojek driver, he actually was able to adopt orphans and together with his wife. And that's when I actually realized the potentials of Gojek as on-demand platform for Indonesian. So not only for customers, but also to like 60% of the underrepresented informal workers in Indonesia. And he's not alone. Currently, we have around 3 million driver partners and also merchant partners across three main cities in Southeast Asia. And all of them depend on their day-to-day livings actually on the platform. And together, just from Indonesian perspective, we've actually contributed 2% of the GDP, which is quite amazing, I would say. And then we have around 20 services, and it's actually very funny because when I imagine again when I graduated as a math student, right, I was very confused what I wanted to do, and then never ever in my wildest imaginations when that I would imagine that mathematics could actually power products which eventually will have profound impact for society, right? And we, in each of these 20 services that we have at Gojek, each of these services actually could and have been powered by a machine learning system that we built. So it's quite amazing, right? And it becomes a verb. Like if you walk on the street in Jakarta, you will actually hear people say that, hey, let's Gojek this and let's Gojek that. So it becomes like an integral part of people's life, right? And in fact, 1 out of 4 people in Indonesia has actually Gojek installed in their mobile. Next thing I will discuss about promo optimization engine at Gojek, and I will start very simple with the problem framing. So we have a set of vouchers, right, that we want to allocate to our user base. Just to give you some ideas about the scale. So on a monthly basis, we allocate around 100 million vouchers to our user base, right? And in each of this campaign, it has various objectives. You can imagine, for example, an objective to get people to familiarize themselves with the app. But we can also like think of an objective as in nurturing people from one-time user into loyal users. So we can actually layer the problem statement with multiple objectives. In addition to this, we also can add the budget constraint into this problem statement. And again, even though I say vouchers, but actually we have like 15 different incentive channels at Gojek, which we can optimize. But just for the sake of simplicity, I will use vouchers as a reference in my talk. So traditionally, marketers will resort into propensity model, basically. So a very tangible way to think about it is by imagining user segmentations where vouchers will be allocated based on user segment. But we want to evolve this approach. We actually want to use a concept called Uplift or counterfactual models, where we add another variable into the problem. So instead of saying that what will be the probability of conversions, giving certain user attributes, we want to add another layer of information. And that information is the type of treatments that we do, the type of vouchers that we give to them. So I want to be able to predict the incremental uplift of certain metrics of interest, given a certain features, if we give a user a certain treatment, right? So that's the problem framing. And then if we were to plot users into various segments, right, based on their response probability conditional on treatments, we can actually like divide it into 4 areas, right? And what we are truly interested in is really the green region. So these are the users who will respond only if we give them treatments, right? And I think for the rest, if I take an example, the sure things, right? So these are users who will basically do transactions, or will basically like respond to our vouchers, right? Irrespective whether if we treat it or if we don't treat them, they'll basically behave the same, right? So they will always convert. So these are the users that we want to leave alone, as an example. And the next thing, I'll just give you the overview of the system. So it's actually a machine learning system. So it's not really like a model. So it's a machine learning system. And within the system, we have various modules, right? One module will allow us to plug in various different models into the system. We have in fact like a couple of variations. Like we have a deep learning models, we have generative models. We also have doubly robust machine learning that we are using in productions, and we're can actually experiment with various different models in a very easy way, using the tooling and the pipelines that we've created, right? Another thing is that in terms of impact, we've actually generated 30 to 40% better efficiency compared to a manual campaign, and that's actually excluded the efficiency that we gain by doing automation. So it's quite a profound the impact of creating this machine learning system, right? I've also incorporated like multi-stage optimizations from predictions, and then we basically like combine various different signals into an integer programming type of optimization, right? In order to kind of like calculate the probability and also like the budget that we will basically hit if we were to allocate a voucher to some certain set of users. On to the next slide. So I'll basically go to the several model variants that we have in productions, right? So number one, we have a high-sci model. So this is like a deep learning based architecture where we introduce the notions of encoder and decoder network, which allows us basically to do the two things, right? So number one, it will allow us to do debiasing of the features, the covariates, right? And the second is that it allows us to really map the high dimensional data into lower dimensional data. And the resulting covariates will then be fed into a predictive layer. We basically who will allow us to do the like a normal predictions, right, as we know. And another important features of this architecture as well is that it will allow us to plug in various objective, right? Maybe like if you recall again that the model comprises of two different blocks, like cost predictions and demand predictions. By using the high-sci architecture, it actually will allow us to train two objectives at the same time. Another architecture we borrowed from JNET. So JNET is basically an architecture that takes advantage of the generator and discriminator layer, right? And what it allows us to do is that it will allow us to learn the counterfactual data generated by generator, and then the discriminator actually will try to differentiate the results, right? And then the desired outcome will be like if the discriminator cannot actually discriminate the data generated by generator, the counterfactual data especially, and then we feed back again this data, the counterfactual data generated by generator into another Jan block, right? And then the task of the Jan block will be to predict the incremental treatment effect. And of course, what's very important for us is that to kind of like move from various type of models, right? So we've talked about the propensity models. We're trying in now response and or uplift models, but in the future we also want to move into more adaptive type of models, which allows us to incorporate signals like the time into the allocations of the vouchers that we have. Now it comes to machine learning productions, and then machine learning productions is not as straightforward as one might thought, right? I mean, there's definitely a gap between expectation and reality. And at Gojek, it's very non-trivial because of the scale at we operate. We need to think about various different factors, right? What will be the SLA? What will be the API contract, success metric, even the way we organize the teams, right? So it all plays out in the success of deploying machine learning system. And these are some of the desired properties of the machine learning systems at Gojek. So number one is that we want the system to be able to allow us to experiment in a very easy way, and it should allow us also to experiment with various type of experimentation designs, right? A/B testing is one thing. Another example is a switchback experimentations, which is designed really to cater for network effect that we have within our data. Another thing is that we want the system also to be iterated very fast, right? And we could deploy it also in a very scalable ways. And then we used to, most of our systems used to basically adopt a monolith architecture, but more and more we are moving into microservice architecture. And what it allows us to do, it allows us really to kind of like create demarcations between tasks and functions between various teams who are involved in the creation of machine learning system. And then basically like each of them will be able to work at their own pace or own pace. And then what also it allows us to do is that like given the fact that each of the team will operate at their own pace, right? There will not be a block by each other's basically. So it is really also like a fundamental change in the way we do machine learning system at Gojek. Another thing is that we want also the system to be able to be evaluated in real time, right? We want to have a UI, and you can just type the versions of the models, and you will immediately see the performance of the models, right? Another thing is that in terms of scalability, so this is also very important because we want to deploy the models in many regions that we have. We want the systems to be able to deploy thousands of models simultaneously. And then for us to be able to kind of like simplify the whole process just by basically creating like a set of configurations among others, right? And then using these configurations, the models will be able to be deployed instantly. Yes, so all these various wishes and properties, right, will actually have actually been enabled by the presence of data science tools. So we tend to build our own toolings, right, within Gojek. There are a couple of them. I will go to some of them in my next slides, right? So we have a feature store, Feast, basically. So Feast is an open source feature store which allows us to kind of like use the same pipeline for training and serving of the data. Another tools that we've deployed is we call it Merlin. So Merlin actually allows data scientists to deploy model very easily. We just like save the binary files, and then it will automatically be deployed in Kubernetes cluster with the proper logging system and many other things. Another thing, we also have a Turing, and we use Turing basically to experiment with various different versions of the model in a very scalable ways, right? Because and it's also like a properly logged, and then we can do some post experimentations afterwards. Last but not least, I would say that building scalable machine learning system is a journey. It is very unique to each organizations and company, but it is really worth it because it will allow basically the companies and organizations to unlock massive values from their data. That's it. Thank you very much for the chance and the attention.
All right, thank you so much, Syafri, for the talk. We have few questions from the audience. Let me pick two of them. The first question is, from an organization perspective, what are some aspects that you think need to be taken care when building a scalable machine learning system?
Yeah, thank you so very much, Robert, for your questions. I think it's a very relevant questions, right? Because in my slides, I have discussed a lot about like technical aspects of deploying machine learning systems, but in addition to that, like organizational aspects are as important, right? In order to kind of enable the team to do so. So number one, I would say it's about how we organize the teams in order to have like an optimal collaborations, right? Just to give you an example, data scientists and product engineers, they both of them, they have their own like various ways to manage sprint, right? There are so many data dependencies for data scientists, while it might be very different with product engineers, right? And really like shifting to microservices slash API approaches actually allows both of the team to move at their own pace, right? And then integrate later on, so they will not be blocked by each other's actually. So that's number one, right? Number two, I would say executive sponsor plays a very different plays a very important role in this, because like building machine learning system, as I mentioned earlier, is a journey. It took a very long time. I remember that when we deployed our first machine learning system, it took us like one and a half years basically to find the actual pattern, right? It was quite a painful journey, and in those journey, executives really need to be patient, because sometimes the results do not manifest immediately. So that's why the executive sponsor will actually play a very big role in this journey. Yeah.
Yeah, absolutely agree. Right? Collaboration and executive sponsor. I think we can quickly go to the second question. So the second question is regarding the data. Does Gojek include third-party or competitor data? How to ensure that the promo is more appealing compared to the other platform in terms of price competitiveness?
Yeah, so definitely, like most of the data that we use in our machine learning systems come from internally, right? Because it will represent our customer behavior better, because they basically you kind of like adjust to like a micro signals that they have done in our app, right? In terms of like a competitor data, we don't actually use it in our machine learning system. We probably use it more from like qualitative perspective to give us insight about how to structure the kind of like incentives, right, in the right in a very optimal way. But the source of the machine learning systems are it's actually primarily from internal data. Yeah.
Got it. Thank you for the answer, and I hope that answered the question. With that, we will end this session. And for the audience, you may now leave this room and please join the fireside chat in the main room. Thank you and see you there.